Alright friends, welcome back. In this video we're going to go ahead and move on in our discussions of section 4.3 of your textbook and continue to talk about conic sections. So if you didn't have a chance to catch the day 1 video, really make sure that you catch that one before moving on to this one. And in this video we're specifically going to go ahead and move on to a different type of conic section. So dealing with the exact same interactive as in the last video. Again, the idea is that we have this double napped cone and we're just going to cut it in a certain way and then take a look at the shape of the cross section. In the last video we talked about circles, so that's what we get whenever we cut a cone horizontally. But if I go ahead and take our cut and angle it a little bit so it just kind of goes through one of the cones and not the other here, you can definitely see that the shape that we make is not going to be a circle. Instead, what we're going to make is another familiar shape that we have seen earlier this year, and that is going to be this outline shape, or in other words, a parabola. Okay, so it turns out that a parabola, much like a circle, is another example of a conic section, again, because that is a shape we get by cutting through this double-napped cone in a particular way. Okay, and so that's going to be the topic of this video, is we're going to revisit parabolas, and we're also going to take a look at graphs of parabolas that maybe we haven't necessarily seen before, but that would be how we go ahead and look at a parabola as a conic section. Okay, now here what we have is basically a definition for a parabola that is a little bit more in terms of geometry instead of in terms of algebra that we've seen in the past. Okay, and so to make this abundantly clear, what we're looking at here is this situation. The reason that we get the shape that we get whenever we're looking at a parabola is because we're trying to look at the collection of all of the points that are the same distance away from two things. Okay, and so the first thing you could see here is something that we call a focus point. It's something that we have here in orange, and then the other thing is this this horizontal line down here that we've dashed. We're going to give that a name too. We're going to call that the directrix. Okay, and so you can see here that I have a parabola shape drawn, and the idea with the parabola is that it's just the collection or the set of all the points P here that I have here in yellow. I can take this and drag this to any place I want on the parabola. A parabola is just a collection of all points that are the same distance away from the focus as it is away from the directrix. Okay, and so to just make that abundantly clear here, I have this little slider here. We're going to go ahead and highlight that distance from the focus to that point on the parabola, and just again keep in mind I could take this point P and drag this anywhere on the parabola that I want, and it always keeps track of that that distance there for me. I want you to notice that that distance, if I draw from that point straight down to my directrix so that it's perpendicular, that is going to be a distance that we perfectly copy because we have a parabola going on here. Okay, and again, there's nothing special about putting the point P there. I could put this point anywhere on the parabola and then do the slider again, and we could see here that that same distance is just going to get copied and looped all the way around, and that's the idea there. So that's going to happen at any point that I put on the parabola here, and that's kind of what makes a parabola a parabola. Okay. The only other thing I want to investigate here is if I take this point and move it down to the vertex of the parabola, we get that same relationship going on, where the distance from the focus is the same as the distance from the directrix. And so that's going to mean something about our vertex. That's going to mean that the vertex is basically going to be the midpoint between the focus and the directrix. Okay. And so that is something that you can play with in today's Schoology folder, but that's what makes a parabola, is that it is all the points that are an equal distance from the focus and the directrix. So some other terminology I want you to be familiar with is just terminology that we've seen before whenever we've talked about parabolas. So this idea of the axis of symmetry. Keep in mind that's just that mirroring line that the parabola mirrors across. If you remember the directrix too, that is always going to be something that's going to meet the directrix at a 90-degree angle. So the axis of symmetry and the directrix are always going to be perpendicular to each other. The vertex, as we said a moment ago, that's just going to be the midpoint between the focus and the axis of symmetry. That actually is a typo there. That should not say axis of symmetry there. That should instead say the directrix. So it's a little bit of a typo there. We'll go ahead and correct that here for our purposes. So it should be the midpoint between the focus and the directrix instead of the axis of symmetry. There we go. Okay, and so getting into the meat of the video here, what we're going to be asking you guys to do is we're going to be asking you to look at a bunch of equations and then to be able to sketch a graph of those equations by hand, which is the spirit of what we've been doing here in Chapter 4. So we're going to find with parabolas that there's going to be two situations. We're either going to have case 1 or case 2, and the basic difference between them is you notice here in case 1 that this is an example of a function formula that we have seen before, okay? So when we have the function formula looking like this, y is equal to a times x minus h squared plus k, this is our standard form for a quadratic function here, and this always produced a parabola that opens up or opens down. Okay, so I like to refer to these as vertical parabolas because they either open up or they open down. Okay, and then you can see here that what we have going on is we have a bunch of formulas here dealing with these values that you could find within the formula. So remember that h and k, those are always the coordinates of the vertex. So over here in my pictures, the vertex would be either right here or right there. That would be a point with coordinates in the xy plane. And then as we go through, you'll notice that we also use those values of h and k throughout all the rest of these formulas here. But you notice that another value that we use is this value of a. And that value of a is the number sitting in front of that quantity that's being squared, okay? And so that comes into play when you calculate the coordinates of your focus and also when you calculate your directrix, okay? So just to be clear here, when you're looking at the focus formula here, keep in mind that that is a point with two coordinates. Your x coordinate in the case 1 here is just going to be h, and then the y coordinate is going to be the number that you get after applying this formula here. So that's going to be your y coordinate of that point. For the directrix here, because you have a vertical parabola, your directrix is either going to be a horizontal line on that first picture or a horizontal line on this second picture here. And so for that reason, you see here that y equals is in the directrix. That means that this is going to be an example of a hoi, or a horizontal line. And also the axis of symmetry, remember, is always perpendicular to that. That will go vertically through our parabola so that we mirror across it. That is going to be a vux. So just a couple of different things that we've seen in the past. Now that's case 1. That's a case that we're nice and used to by now. But case 2 is going to be a different case here. Okay, and so this is going to be the case where you're going to have a parabola that opens to the left or to the right. Okay, and the vertex for these would be these points here. So boom and boom. And then you notice that this works pretty much the exact same way. You notice that in case 2, you have a function formula where h and k have basically switched seats in the function formula, but we still go ahead and consider the point with coordinates hk in that order to be the vertex. And then we also use h and k throughout all these different calculations down here. And we also go ahead and still use that number a that's in front to calculate the x coordinate of our focus and also to calculate our directrix. Just to point this out, the directrix in this case, because on my pictures over here, the directrix would have to be a vertical line, then that is going to be a vux here in case 2. And the axis of symmetry, that is going to be perpendicular to it. And again, my pictures are not that great because they're just free-handed here, but the axis of symmetry in case 2 is going to be a hoi, or a horizontal line. Okay, and so what you're going to have to ask yourself as you move on to some examples is which one of these cases are you dealing with, okay? And the way that you figure that out is you look at what is being squared. So you'll notice that in case 1, what's being squared is this quantity dealing with x, okay? And so this is going to be the x squared case. So you have to look at what's being squared. If x is the thing being squared, then that's going to be case 1. You notice over here in this case, the thing that's being squared, of course, is the variable y. And so that's how you tell if it's a case 2. So if x is the thing being squared, you're going to have a vertical parabola. If y is the thing being squared, you're going to have a horizontal parabola. And basically the examples that are to follow here, you'll notice that I've already done a couple of them, are basically just going to be giving you the function formula, and they're going to ask you to write it in standard form if it's not already, to point out the vertex, the focus, the directrix, and the axis of symmetry, and then you'll go ahead and create a plot of it. So I've already done number 1 here. You'll notice that number 1 was just given to us in the standard form. This would be a case where y is the thing being squared, so that would be a case 2 parabola. And you notice I'm just kind of going through, I already pointed out what h and k are, and I'm just using that to kind of inform my my formulas here for the rest of the different measurable aspects, and then using that information to draw a nice picture is something that would be a complete problem. Even in Part B, this is something else that would be a complete problem. Again, just to kind of save some time in the video, these would be the simpler examples in the notes here, so I'm just going to go ahead and flash these up on the screen and let you read through them. But basically, again, you might have a case where the thing that's being squared is x, so you might have to go through and solve that for y, and we'll talk about that here as we get to some examples. But yeah, you might have a case where you might have to rearrange some terms and then get all your different measurable aspects and then draw the parabola accordingly. what I'd like to do here is go ahead and pick up with the next 3 examples that we'll do together. So here in part C, again, if you're asking yourself which case this is, I guess I've already kind of spoiled the punchline, as you can see there, but this is going to be a case 2 because, again, the thing being squared is this quantity with y in it. Okay, that's the thing that has the exponent of 2. So this is going to be a case 2. Now, if you take a look at what we have and you compare it to over here to what we want, over here what we want has this quantity y minus k squared. And if you take a look here, that's already something that we've got going on over here in the function formula. We already have something that looks an awful lot like that part of what we want. So this already looks an awful lot like y minus k squared in part C. Now what you also notice here that what we want over here in case 2 is we want x to be completely by itself in the form that we want. And so x is not by itself over here in our example, which just of course means we're going to have to go through and get it by itself. Okay, a couple different ways you could observe that. But the first thing that we'll do here is we'll go ahead and get rid of this 4 out in front of this quantity on the right-hand side. And of course, that is a 4 times, and you can get rid of multiplication by dividing. But I encourage you for these types of problems here when we're dealing with parabolas to specifically, instead of dividing by 4, specifically go ahead and look at this as multiplying both sides by 1/4. And we all know that that would be equivalent to dividing by 4 on both sides, but there's a reason for that, and we're going to get into that a little bit later on. So on the left-hand side, we're just going to write that as 1/4 times y minus 1 squared, and that's going to be equal to simply x minus 3, getting rid of that 4 in front on the right-hand side. And now, of course, we just simply have a minus 3 on the right, so we can just go ahead and get rid of that by adding 3, which I'll just go ahead and tack on to the back of the left-hand side there. And the left-hand side will simply just look like 1/4 times y minus 1 squared plus 3 is equal to x, and then to just, make it look more like what we want over here in case 2, I might just swap my left and my right-hand sides here and go ahead and rewrite this as x times 1/4 times the quantity y minus 1 squared plus 3. And this will give us the ability to go ahead and match this up to the form that we wanted and then pick out what's playing the role of h and k and a respectively here, okay? So if you look closely with what we have worked with here, it looks like y minus the number k, playing the role of k is going to be y minus the number 1 up here. So playing the role of k is 1. And then you notice in the very back of my formula, I have the plus h. So playing the role of h here is pretty plainly a 3. And this gives us the immediate ability to go ahead and point out what our vertex is here in this problem. Because remember, that is just going to be the point with those coordinates, h and k. And so our vertex here is going to be in that order, h as the x coordinate, k as the y coordinate. So here that would be the point with coordinates 3 and then 1. Okay, so we immediately know what our vertex is by just taking a look at our function written in the way that we wanted, the standard form, and then we're able to pick out those values and get our vertex that way. Next, what we want is the focus. Okay, so the focus, according to case 2, is going to be this formula here. Now remember that this first expression right here, that is the x coordinate by itself, comma, and then we have the y coordinate. Okay, so we're going to have to do a little bit of calculating for the x coordinate here, and that is going to be the same h as before, so that is going to be 3, but then we're going to add on 1/4 times whatever's playing the role of a, and that's going to be our x coordinate, and then for our y coordinate, that's simply just going to be the number 1, because that's just simply k. Now playing the role of a for us, if you look up here and compare, that is going to be played by the number 1/4 in this problem. And this is exactly why I encouraged you to look at this as multiplying by 1/4 instead of dividing by 4 in the very beginning. Because if you had it written like that, then it would be a little bit more difficult to notice that that's what's playing the role of a here. So here we're going to say that playing the role of a is just simply 1/4. And that gives us the ability to do this with some quick mental math, because you'll notice in the denominator there, 4 times 1/4, that's just going to be 1. We have 1/1, and that's just going to make 1. So 3 plus 1, of course, is going to make 4. So the focus turns out to be a point with coordinates 4 and then 1. And so that is something that we can go ahead and plot very easily as we move on to our picture here in a moment. For the next little bit, we have the directrix, and that, of course, is going to be a vertical line here in case 2, and of course the formula for that is sitting right here, so it looks like we have to take h minus that quantity 1/4a. So you notice that that's very similar to how you got your x coordinate for the focus, as how you get the directrix. So the only thing that changes is that operation in between. Instead of a plus, we're going to perform a minus here. So for the directrix, we're going to say that it's a vux, it's an x equals line, and that's going to be our 3 minus 1/4 times 1/4. And we already did that part mentally. We already know that 1/4 times 1/4 is simply just 1. So that's just 3 minus 1, or in other words, that's just simply going to give us 2. So there's our directrix there. Again, keep in mind that is a vertical line or a vux. And then keep in mind also the axis of symmetry. That has the easiest formula of the bunch. You can see it up top there. It just says y is equal to k. And so y is going to be equal to whatever number is playing the role of k for us. And here that's just going to simply be 1. And that is going to be all of our different measures of the parabola here. Okay, my screen just blipped, so hopefully the video is still running. Hopefully you guys are still with me there. All right, and so we can get all these different measurable aspects by just taking a look at those formulas in each case, and then now we can go ahead and take all that information and bring it over here to the grid. Now, you notice that just like in the last video when we talked about circles, you don't have a set of axes here already drawn. You're going to have to draw those yourself. And so the way that I've already encouraged you to draw this, just like we did for circles, is we're going to go ahead and place the first point at the direct middle of this grid. And the very first point that we're going to graph is, of course, the vertex, which, of course, over here we already calculated has coordinates 3, 1. Okay? Now, we're going to get to drawing the rest of that parabola here in just a moment, but what I want to do is I want to go ahead and make sure to get our axes correctly drawn, because our vertex was supposed to be at a point with coordinates 3, 1. Which would mean that from the origin, I'd have to go 3 to the right and 1 up. Well, I want to work backwards from that, because now I'm not going from the origin to my vertex. I'm going from my vertex to my origin, so I know where to place my axes. So I'm going to go ahead and work in the opposite directions as what my vertex says to go in here. So if I had to go to the right 3 to get to my vertex, I'm going to go to the left 3 with my y-axis to go ahead and place that correctly, okay? And so I'm going to go ahead and place that there for my y-axis. And then for my x-axis, I'm just going to go ahead and take my straight edge horizontally like this. And then again, keep in mind, to get to my vertex, I'd have to go up 1, but I'm going from my vertex backwards to my origin. So I'm going to go down 1, and that's where I would go ahead and place my x-axis there. Okay, and that must mean that this is the origin, and it looks like my point has been plotted correctly there. So again, that's just a quick way to go ahead and place your axes when you've already drawn your vertex in the center of the grid that I provided here for you. Okay, now to get the rest of the parabola, what we could do is we could go ahead and draw in that directrix and that focus, and we could start drawing all of the list of points that are the same distance away from both. That's going to get a little bit tedious and would require that we have some measuring tools like a ruler and that kind of thing. So I'm not going to require that you do that. Instead, what I'm going to require that you guys do is keep in mind that the way that all parabolas work is that you start at the vertex, and then one way that you could look at this is that you could sprout out 1 unit in both directions from the vertex, right? So that would be going +1 and then in the -1 direction. Now, in order to go up, we would have to go up a length of whatever that number is squared, and then times a. So for our purposes here, just to make this as simple as possible, from the vertex that we already have plotted, we're just going to go 1 to the left and 1 to the right, and then from there we're going to go up a matter of that a number that we found from earlier, which is why I'm coloring it pink here. Okay, this is going to be the way that we're going to kind of give ourselves some guidelines for being able to draw the entire shape here, okay? So that's going to be the way that we're going to think about drawing our parabola in general. We're going to start at the vertex, we're going to sprout 1 to the left, 1 to the right, and then from both of those places, we're going to go up a matter of whatever's playing the role of A. And so here, playing the role of A for us is simply just 1/4, and so starting here at the vertex, we're just going to go 1 to the left, 1 to the right, and then we're just going to kind of have to eyeball what 1/4 of 1 grid square would look like. So I'm going to go 1 to the right here, and then I'm going to go up 1/4. I think that approximately would be about right there, and then same thing from the vertex, I'm going to sprout left, and then go up a matter of 1/4, and that would be about right there. You could continue, but I think this is just a good enough approximation for getting the rest of it. You can see that our parabola is going to be very wide here. And again, I'm just going to go ahead and allow you guys to sketch the rest simply by hand. Keep in mind that this is a symmetric shape, so the right should look like it mirrors over onto the left, at least the best you can anyway, and that would be a really good approximation for what the rest of that might look like, okay? So that would be a complete problem. So not too bad. You did have to notice which case you were in. You just have to look at what variable you're squaring. Here, that's the y, so that's going to be a case 2. And then rewriting it so that it looks a little bit more like the form that you want, and then being able to kind of get your measurable aspects from there, and then draw your grid. Let's take a look at this next one, right? So part D, we have this function formula here. Again, what is being squared? Well, if you take a look, it looks like x is the thing being squared, so that's going to make this a case 1. Okay, now you'll notice that we have a bunch of variables showing up in a bunch of different places here, and so what this is going to mean is that we're going to have to go ahead and do a process that's going to make what we've got look like what we want. And keep in mind, what we want has this quantity in it. It has this x minus h squared in it. And so in order to achieve that, what we're going to have to do is that process that we reviewed in the last video when we talked about circles. We're going to have to complete the square here. Okay, and so again, if it's been a while since you've completed the square, then make sure to catch the last video where we reviewed that, but we're going to go ahead and do that here. Now, because I do want this quantity with x to be squared in my final form, I'm only going to deal with the stuff that deals with x here on the left-hand side, which means that everything else I'm going to go ahead and bring over to the right-hand side. And I could just simply do that using my inverse operations here. So I'm going to go ahead and rewrite this as x squared plus 6x. Leave a little bit of space. I'm going to say equals 8y minus 25. Okay? Now I left that space there because this is the step where we complete the square. And so remember, the way we do that is we take a look at this b number, we divide it by 2, and then square the result of that. So 6 divided by 2 would be 3. Squaring the result of that, that would give us 9. And so that trinomial, x squared plus 6x plus 9, that's something that we can now rewrite as a perfect square trinomial and say x plus 3 all squared, okay? And again, the whole point of doing that is because now what we have looks an awful lot like what we wanted from over here in case 1, okay? I might even be able to reason that playing the role of h now is -3, but we're going to get that a little bit later on whenever we've completed this whole thing, because remember that whatever you introduce fresh to one side, you're also going to have to introduce fresh to the other side. So if I introduced a plus 9 out of nowhere on the left-hand side, I'm going to also have to do that same thing on the right-hand side to keep things balanced. And so that's going to combine with that -25 there. And so on the right-hand side, I'm going to end up with 8y minus 16. Okay? And now what we'll do is we'll go ahead and continue by observing that what I want to end up with has this. It's got y equals by itself, okay? And I don't have y by itself in what I've got down here. So what I'm going to do now is perform some inverse operations until y is by itself. So I'm going to add 16 to both sides. The left-hand side is going to look like x plus 3 squared plus 16 is equal to 8y. And then I'm going to get rid of that 8 in front. Again, my tip for this video is to go ahead and look at that as to multiplying both sides by 1/8. That's equivalent to dividing by 8, and it's going to give us a little bit of an easier time realizing later on what the a value is going to be. Okay? Now, real quick, this 1/8 that we are multiplying times the entire left-hand side, that is going to have to get distributed. So when I distribute it to that first quantity, that's really easy to write because that would just simply be 1/8 times x plus 3 squared. But we do have to do that second distribution, which is 1/8 times 16. And 1/8 of 16, of course, is going to be the number 2. So we have this all equaling y, and I might just flip that around just for the sake of being able to match this up to our standard form here. So that's going to be 1/8 times x plus 3 squared plus 2, and that's our standard form. We can now go ahead and match this up to our case 1 and be able to pick out what those values of a and h and k are going to be, and then be able to continue by getting all those measures in the problem here, okay? Now, playing the role of k here, since it's just the number plus at the end, that's going to simply be 2. Here, again, we talked about this earlier, but this is going to be x plus 3, and in the form that I want, I have x minus the number h. So I'm going to have to rewrite this plus as a minus, and we could do that simply by just simply saying x minus -3, okay? So that means playing the role of h is actually going to be -3 here. And then you can see here pretty plainly that playing the role of the number a is simply just going to be this fraction out front. Again, that's exactly why I recommended that you multiply times 1/8 earlier instead of divided both sides by 8. So now that you know what a and h and k are, you automatically know that the vertex now is going to be at that point with coordinates -3, 2. You automatically know that the focus now is going to be, again, just following the formula here, we're just going to add on 1 over 4 times a to our k value here. So that means that our x value is going to stay the same, but we're going to simply take 2 plus whatever 1 divided by 4 times our a value is going to be. Now our a value is 1/8. 4 times an eighth is going to be 1/2, and 1 divided by 1/2 is actually going to be 2. So when you take 2 plus 2, that's actually going to give you 4 in a problem like this, okay? For the directrix, same thing, or a similar thing rather. We're going to take 2, which is playing the role of k. We're going to subtract off what we said 1 over 4a is going to be. And so because we said that that's going to be 2 earlier, that's going to be resulting in the line y is equal to 0, aka that is just simply going to be the x-axis in this picture. And then finally for the axis of symmetry, simplest formula here, that's just going to be x is equal to h, and that's just simply going to be -3 in this case, okay? So while all these things are something I am going to ask you to find, all you need to do for your picture is just get that parabola drawn with the axes, okay? And so let's do that here simply. So let's go ahead and plot that vertex right in the middle of our grid. And then we'll get our axes drawn here. So we'll start off with our x-axis because my ruler is already horizontal here. My vertex over here, you can see, is at a point with coordinates -3, 2. That means that from the origin, I'd have to go 3 to the left and then 2 up. But because I'm going from my vertex back to the origin, I'm working backwards here. So I'm going to have to go ahead and drop my x-axis down 2 so that it looks like I'd have to climb 2 to get up to my vertex. Okay? So I'm going to go ahead and plot that as my x-axis there. And then for my y-axis, I'm going to start here at my vertex again. And then again, because my x-coordinate is -3, I'd have to go from the origin to the vertex, the left 3. But I'm going to work backwards from that and go to the right 3 and place my, my y-axis right there. And again, wherever you place these axes, it should look exactly like you have gone from the origin to that vertex point up there to plot that correctly. Okay, and so I think that looks pretty good for us. Now, in order to get the rest, remember that, that convention from before. If I start at the vertex here, and I go 1 to the right, I'm just going to go up a matter of whatever's playing the role of A. And then it's the same thing working the opposite direction, right? If I go -1 to the left, I'm going to go up the matter of whatever is playing the role of A. Now for us here, playing the role of A is a fraction 1/8. So this is going to be really one of those things that is going to be opening up very, very wide here for us, because going up 1/8 of a grid square is not going to be going up very long, okay? And again, you could continue in that same exact pattern here, but this is going to be enough to give us a nice complete picture of what this parabola may look like, or at least give us the general idea. So something that looks a little bit like that, okay? And so one last example here in the video, and then we'll call it quits. I know it's a relatively longer one, but I just want to make sure that we've covered enough examples here to where this starts to make sense here for you. We're going to take a look at part E. Okay, we'll just do this one really quickly. Again, because y is the thing being squared, that makes this a case 2 parabola. And so you notice I've already got some things dealing with y. I'm going to go ahead and take everything else over to the other side. And so I'm going to rewrite this as y squared minus 4y, leave a space, is equal to 4x after bringing that over. And then we're going to complete the square. So -4 divided by 2 and squared is just going to give us plus 4, which I'm going to go ahead and also introduce to the other side because I'm keeping things balanced in my equation. And now on the left-hand side, this is just simply going to be y minus 2 squared is equal to 4x plus 4. Okay? And next step here would be, of course, to go ahead and work towards getting this x isolated, so get it completely by itself like we want. And so that's going to be some inverse operations here. So that's going to be y minus 2 squared minus 4 is equal to 4x if I subtract 4 from both sides. And then to go ahead and get x by itself here, I might just go ahead and multiply both sides by a fourth. Again, instead of multiplying by, or not multiplying, but dividing by 4 on both sides, so we can more easily figure out what is playing the role of a later bit on. And then 1/4 we can distribute into both. And we're going to see here that x by itself is going to be equal to 1/4 times the quantity y minus 2 squared minus 1. Okay? In which case you can see here that playing the role of a is simply going to be 1/4. And then playing the role of h is going to be 2. Playing the role of k is actually going to be -1, because keep in mind up here in the function formula it does say plus h, and as a matter of fact I swapped around my h and my k, so let me go ahead and change that here. K should be 2 and h should be -1, okay? And so that's going to tell us here that the vertex is going to be at a point with coordinates -1, 2, again because the order goes hk. For the focus here, we're just going to go ahead and treat A as a 1/4, and then go ahead and do this quantity mentally, right? So that would be 1 divided by 4 times 1/4. 4 times 1/4 is just 1. 1 divided by 1 is just simply 1. And so to get the x-coordinate for my, my focus, I just need to go ahead and take my x-coordinate for my vertex and add on 1. And so that would be -1 plus 1, or in other words, just simply 0, okay? For my directrix, that's going to be a vux. Similar calculation, we just need to go ahead and subtract it now. And so if I have -1 minus 1, that's actually going to give us -2. So that's going to give us the vux, or the vertical line equation, x is equal to -2. And then finally, for the axis of symmetry, that is simply going to be y is equal to k. And for our purposes here, that's going to be y is equal to +2. Okay, we're going to come over here to the grid, and we're going to place that center point in the middle of our grid. That's our vertex. And then we're going to go ahead and place our axes. Now, our vertex was at a point with coordinates -1, 2. So that means that I have to go from the origin to this point to the left 1 and then up 2. So I'm going to work backwards from that. I'm going to go to the right 1 and then plot my, my y-axis. And then from my vertex, I'm going to go ahead and go down 2 and plot my x-axis. Okay, I think that's the easiest way to go ahead and look at your axes there, is by starting at the vertex and working backwards. Okay, and again, at this point, it should look like that point is plotted correctly. Okay, so from the origin to that point, that should be the point with coordinates -1, 2. And then finally now we're going to stick with that parabola shape, playing the role of A as 1/4, so just sprouting out once to the left and once to the right, and then going up a matter of 1/4. That would be something that looks a little bit like the following. Now, keep in mind that this is a case 2. This is going to be a horizontal parabola. So for our purposes here, what we need to keep in mind is that when we start at our vertex, we're instead going to now climb up 1 and down 1. Okay, so this is more what we're going to have right here, because then we're going to go over a length of A and over a length of A to get our parabola here. So playing the role of A is 1/4 here, so if I sprout up 1 and go over a 4th, sprout down and go over a 4th, this is going to be a case 2 parabola that opens up to the right, so something that looks a little bit like this. Okay, so just at least the best we can there. All right, and that's going to do it for this video. So thank you for paying attention here. I know this was a long one, but that is going to be all we have for parabolas and taking a look at a parabola as a conic section. So if you guys have any questions at all, feel free, as always, to let me know. But that's all I have for this one. Thank you very much for your attention, and I'll speak to you in the next one.